So here's our lesson on basic unit conversions, and this is going to be the introductory part of this particular lesson. So each measured quantity is going to be associated with some unit of measurement, and there's two basic systems of measurement that are currently in use: the imperial or British system and the Système International (SI), or what we commonly refer to as the metric system. Now we will need techniques for converting within and between these two systems, because most of the companies that we deal with are either, in North America or could be worldwide. So we will be dealing with both systems. Let's take a look at some of the typical units from the two systems. So measurements for length. Now remember, length is one dimensional. So here's a line. There's a 1D unit. Some imperial measures for length are inches, feet, yards, miles, rods, chains, and furlongs. Now this is not a complete list, but just to show you some of the different ones that are out there. Most of us should be familiar with inches, feet, yards, and miles. These rod changes and furlongs. Furlongs maybe for horse races, you might know them for there. In the metric system, we'll have meters, centimeters, millimeters, kilometers. And again, there's going to be quite a few of those. If we move on to area, that's two-dimensional. So here we have a square. We can see that, we'll have that cross-sectional area. There's our 2D. Here's dimension 1 and dimension 2. Some imperial units for area. Well, we can just square the inches, square the feet, square the yards, square the miles. And we can even have some different units. Here's an acre, abbreviated AC. That's an imperial unit for area. Going over to the metric system, again, we can square the meters, square the centimeters, square the millimeters, square the kilometers, and we even have specialized units in the metric system, something called hectares, abbreviated HA. Now, why we have squares here is that if we go back to our little 2D diagram, well, if this is inches and that's inches, well, to get that area, we'll have to multiply inches by inches, so there's our square. Or if it's millimeters times millimeters, well, millimeters times millimeters is millimeters squared. Let's take a look at now three-dimensional measurements we might use. And again, here's a 3D object. It's just a basic cube. And you should be anticipating this. Well, we just take our length measurement, and now instead of squaring it for area, we cube it for volume. So cube inches, feet cubed, yards cubed. We have some other units: gallons, ounces, pints, quarts, and here's one that might not be familiar to us, something called acre feet. Now remember, acres were area, so that's a square type of term, an area type term, and then times feet, area times a length, is going to give us volume. So say if this was inches, inches times inches times inches, well, there's our cube, and then we maybe have this top surface in acres, and then this is in feet, so acre feet would be the volume unit. In metric, well, likewise, we're going to cube the meters, cube the centimeters, cube the millimeters. We also have liters, and we have milliliters. And again, there's many more units than we're seeing so far here. This is just sort of a snippet to give us some typical examples. Let's take a look at mass now. Now, mass is when we're weighing something. So in the imperial system, we have pounds. LB is the abbreviation for pounds. We've got ounces, we've got tons, and we have long and short tons. And we have to know when we're dealing with one or the other. In the metric system, we have grams, milligrams, kilograms, and then metric tons, spelled T-O-N-N-E-S, or abbreviated just T. So tons, we're going to have to be able to differentiate not just between metric and imperial, but also within imperial, long and short. And then just remember that there are many other units than the ones I've listed here. These are just some of the basic ones that we'll be seeing, but we will be seeing other ones throughout the course. Now, in our metric system, it's a little bit easier to use than the imperial system because it's based on powers of 10. So let's take a look at a length example, and our base unit is going to be our meter. And we're going to start off with something called a mega. Now, a mega is an abbreviation capital M. It means that it's bigger than our base unit, By how much? Well, it's 10 to the 6 times bigger. So 1 megameter is 10 to the 6 or 1,000,000 meters. We have another measurement prefix, kilo. This should be relatively common for us, given by a lowercase k. What's the multiplier here? Well, it's 10 to the 3 times. So a kilo is 10 to the 3 or 1,000 times bigger than our base unit. So 1 kilometer is 1,000 meters. Another example, hecto, not one that's commonly used for us. Abbreviated H. How much bigger is this than our basic unit? Well, it's 10 to the 2 or 100 times bigger. So 1 hectometer is 100 meters. Look at another one that's bigger, a deca. Again, not one we very often use. DA is the abbreviation. This one is going to be 10 to the 1 or just 10 times bigger than our base unit. So 1 decameter is 10 meters. So we can see that our powers of 10 are coming out in the multipliers, but also in the statements of equivalences. Please also note, though, that I have here 10 to the 1, 10 to the 2, 10 to the 3, and then I jump to 10 to the 6. There are prefixes for the 4 and 5. They're just not used as often, so they're not included on this particular table, but they are out there. We've taken a look at some bigger ones now. Let's take a look at some smaller ones. So we have deci as a measurement prefix. The abbreviation is just a single d. Now this is going to be smaller. How much smaller? 10 to the minus 1 times smaller than our base unit. So what we're going to have is 1 decimeter is now 10 to the minus 1 or decimal 1 meters. Centi, abbreviated with a C as a prefix. This is going to be 10 to the minus 2 times smaller. So 1 centimeter is 0.01 meters. So notice how our smaller unit is a decimal value of our base unit. Let's take a look at milli, abbreviated with an M, 10 to the minus 3 times smaller. So 1 millimeter is 0.001 meters. Our small unit is a decimal value of the base unit. Take a look at one last small one, a micro. That's abbreviated with this Greek letter called mu, so it's a sort of a stylized U. This one is quite a bit smaller, 10 to the minus 6 times our base unit. So 1 micrometer or 1 micrometer, or however you like to pronounce it, is 0.000001 meters. So our small measurement is a decimal value of our base unit. Note again, though, that I have 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, and then we jump to 10 to the minus 6. There is a prefix for minus 4 and minus 5, again, not as commonly used. Something we can also do, though, is that in the when we originally did this, we had the one of our prefix units is related to the meters, but we could reverse this and to have 1 meter on this side, and then we'll have different values for the prefixes. So let's take a look at that. And now we can see how 1 meter is a very small megameter. 1 meter is 10 to the minus 3 kilometers. 1 meter is 0.01 hectometers. 1 meter is 0.1 decameters. And then on the smaller side, well, there's 10 decimeters in a meter, 100 centimeters in a meter, 1,000 millimeters in a meter, and this should be 1,000,000 micrometers in a meter. So just watch out for that. There's different ways of interpreting these metrics prefixes, so you'll have to pick whichever you like. And again, recognize this is not a complete list. You can either find it in a textbook or on the internet or whatever source you like. We now need to look at some statements of equivalences. And this is just going to be an equation that expresses the equality between different units of measurements. We have lots of different sources of equivalences. For us in our course, we're going to have our unit conversion tables that, of course, we'll get with tests. We'll have our metric or SI system table of prefixes. We might have problem statements where we can find equivalences. But again, there's going to be many other sources. Your calculator actually has some in it. There's reference books. You can go on the internet, all sorts of different resources. So let's take a look at some examples of equivalences from our two imperial and metric systems. So again, let's do length or one-dimensional. So 12 inches is a foot. 1 chain is equal to 66 feet. 1 mile is 5,280 feet. 100 centimeters is 1 meter. 1 kilometer is 1,000 meters. 1 meter is 10 to the 6 micrometers. Area examples. 1 square foot is 144 square inches. 43,560 square feet is the same as 1 acre. 1 square mile is 640 acres. 1 square meter is 10 to the 4th centimeters squared. Now we have up here that 100 centimeters is the same as 1 meter. Remember, for area we squared things. So we squared the 1 meter and we got 1 meter squared. And now we're going to square the 100 centimeters, and 100 squared is 10 squared squared, or 10 to the 4th, and then centimeters squared. 1 kilometer squared is 10 to the 6th meters squared. 1 hectare is going to be 10 to the 4th square meters. Here's some volume examples. 1,728 cubic inches is the same as 1 cubic foot. 2 pints is 1 quart. 4 quarts is 1 gallon. In metric, 1 decimeter cubed is 10 to the 3 centimeters cubed. 1 milliliter is 1 centimeter cubed. And 1 centimeter cubed is 10 to the minus 3 liters. Let's take a look at some mass examples. 16 ounces is 1 pound. 1 short ton is 2,000 pounds. 1 kilogram is 10 to the 3 grams, or 1,000 grams if you prefer. 1 megagram is 10 to the 6 grams. And 1 metric ton, remember T is metric ton, is 1,000 kilograms. Now, from these statements of equivalences, we said that we could also have them coming from problem statements. So let's look at some examples from problem statements. I have a scenario where 17 structural beams are requiring 10 tons of steel in their fabrication, and each beam has 5 braces. So my equivalences, or equivalents, however you like to say it, there's 17 beams is equivalent to 10 tons of steel, and it is metric tons. And one of my beams is equivalent to or equal to 5 braces. Let's take a look at another example. An engine is consuming 5 gallons of gasoline per hour, and it runs for 15 hours each day. Each gallon of gasoline has a mass of 6.5 pounds. Let's find some equivalences here. 1 hour is equal to 5 gallons of gas. There's our 5 gallons per hour. 1 day is 12 hours. The engine runs for 12 hours each day. And then finally, a gallon of gasoline is 6.5 pounds. So each gallon has a mass of 6.5 pounds. So situational statements can also lead to equivalences. Now this is important because we're going to be using equivalences as unit ratios. So let's see what I mean by that. Well, they're called unit ratios because the ratio has a value of 1. And let's see what that means. So here's an equivalence. We should all know that there's 10 millimeters in 1 centimeter. And I'm going to write that as a unit ratio. And all that means is I'm writing it as a fraction. And I've chosen for my first case to put the millimeters in the top and the centimeters in the bottom. Now the ratio has a value of 1, meaning that this distance here, this 1 distance, is the same as this 1 distance. So it's not to imply that we have 1 in top and the bottom. We don't necessarily have that. We have the same thing being measured, just different units. But I could write the ratio like this, or I could write it with the centimeters in the numerator and the millimeters in the denominator. So this equivalence can be written in 2 different ways depending on what I want to do with that information. Here's another example from imperial. 12 inches is 1 foot. So one ratio I can write is that there's 12 inches in the numerator and 1 foot in the denominator. Alternatively, I could reverse it, 1 foot in the numerator and 12 inches in the denominator. Another example here, let's take one of our situational ones. 17 beams is equal to 10 metric tons of steel. Here's a unit ratio. 17 beams in the numerator, the 10 metric tons of steel in the denominator, or conversely, the 10 tons of steel in the numerator and the 17 beams in the denominator. And we have to recognize that since that these unit ratios are technically equal to one thing, one distance, one situation, multiplying any quantity by that unit ratio doesn't change its numerical value. What happens, though, is that the magnitude and the units of the actual measurements are being altered. And we'll be using these unit ratios, we'll be using this concept of unit ratio in our next lesson, using the unit ratio technique to do conversions.